What we see more and more emanating in the grids worldwide is coming from the situation where in the past we had dedicated big power plants that were just feeding the energy into the consumption via the grid. We see now more and more decentralized energy and generation coming. That is, for example, wind, this is solar production, this is a combined heat and power generation. So all small producers that we see in the grid edges that are very, very decentralized and spread across the country. The grid has never been designed to take up this energy and to manage this kind of a situation. And this is why in the future we see microgrids, which are small parts of the grid that are either connected to the main grid or might also be operated in a disconnected mode that optimize generation, consumption and storage in a particular location, in a particular part. And in the future the grid will consist of the big grids, the high voltage transmission grids and the distribution grids that we know, but there will be lots of microgrids connected to these grids and they will be jointly optimized. So we'll have a mix of a local optimization as well as a general wide area optimization of grids, and that's going to be the future. The use cases and the usage is dependent on the application and the customer. So we have different kinds of customers that are interested in microgrids. For example, institutions. They usually have, like universities, a campus or an area where they want to optimize electricity consumption and electricity generation. And there it's all about optimization of CO2 emissions, and it's about optimization of cost and resiliency, so availability of power. When you talk about industrial customers that might also deploy microgrids, they usually have generation capabilities. They have also a consumption part, and what they want to do is they want to minimize their energy costs while at the same time having resilience and safety and security of power supply available, and they want to cut the costs by cutting the peak load. Then we have other applications, for example remote locations in specific areas worldwide, like islands for example, or decentralized or very remote communities. They are not connected to the grid at all. And what they need is a decentralized power system that enables them to run their grid on a stable basis with resilience, cost efficiently, but at the same time at an adequate cost. So these are the major topics, but then we have a specific topic as well with customers with very high requirements as far as power supply is concerned, like for example army bases. They need a dedicated grid that is independent of the public grid in order to be connected to the public grid and receive the power from there, or on the other side be self-sustainable in cases the public power is not available. The great thing about this project that we have here in Italy, in Savona, is that we have all the ingredients that we need to create a microgrid, which is generation, which is heat production, which is the generation on the photovoltaic side, which is batteries. We all have it on one campus, we all have it in one hand, and we have the capability to, together with our partner here at the university, to bring it together, to optimize it in a very, very comprehensive way and make this microgrid one of the shining and first examples of complex microgrids in Europe and particularly in Italy.